So these and these were the same, right?
Yeah.
These and these were the same.
Yeah.
So were these?
Yeah.
Okay, and so basically, if I sit here and like Alexa said, if I sit here and I multiply 2 and 3, I'll get the same value if I were to add these two that I would get if I did log 6. Okay, what did that do for this one? What was this?
0.7782.
So it was 0.7782 over here. All right. What about these? What was 7? What you guys get for 7?
0.6021.
6021. Okay. Huh?
7 through 10 are on.
7 through 10 were all equal.
Yeah.
Really? Okay, so all of these were okay. So what can you say about that? When I divide them? So if I divide 12 and 3, 80 and 20, 32 and 8, it's all 4. Okay? Yeah, all right. What about this one? What you guys get for this one? 0.9031. What about this one? What about this one?
2.
Oh, 2? Okay. And this one?
2.0969.
So what can you say about these?
5 to the third power.
The power?
The number in front of log is the power. It's 5 to the power 3 is 25, which should be 13.
You guys see that?
Yeah.
Okay, so these all fall into your properties of logarithms, all right? If you are adding two logs that have the same base here, what's the base for these two logs? 10. These are common logarithms that we talked about yesterday. Remember, if there's no base, it's a common log. So if you have the same base and two logs are being added together, you can actually condense them by multiplying whatever is beside them. All right? When you're subtracting, what you guys say I can do? I can divide them. So this would be the log of the same base, a over b. And what about this one?
Log A, B.
A to the b. Very good. Okay? This is known as your product, quotient, and power rules for logarithms. Okay? So if you ever were to like search them, say like, I don't know, if this doesn't make no sense, and you were like to Google search them or something like that, that's what they would come up as, all right? And just look up properties of logarithms. Do you think these are going to work for natural logarithms as well?
Yeah.
Well, let's see. Let's do 15 and 16. Do that in your calculator. See if you get the same thing. Do ln of 2 plus the ln of 3, and see if you get the same thing when you do the ln of 6.
Round
4 places. Yep.
How did you do the element?
It's it should be somewhere near your log.
Yeah, it is the same.
Yeah. What was that? What was the number?
1.79.
All right. So when you're adding them, you can multiply the 2 and the 3, and it'll be the same thing. Let's check 21 and 24. Okay, check 21 and 24. Yep. What's the number?
1.3863.
So 1.3863?
Yep.
Okay. So that works the same. All right, what about over here? Let's do 27 and 28. Yeah, what's the number?
4.8283.
All right, so yes, it applies to natural laws as well. And if you notice, they were the same numbers, but it was ln for one and log for the other. They're not the same, okay? Because remember, they're inverses of different types of functions. Ln is the inverse of e as the base. Okay, you guys remember that from yesterday? And then your logs in these particular cases was your natural log has a base of 10. All right, so don't sit here and think that if you do ln, it's the same thing as the log. It's not. Okay. So we can use these properties to simplify different logarithm expressions to a single logarithm, and vice versa. We can also expand them. So right here, the log of 4 plus the log of 7 can be written as the log of 28, because all I do is multiply 4 and 7. The log of A plus the log of C would be the log of AC. Over here, 6 log X can be written as
Log x to the 6.
log X to the 6. Just remember, this is the power rule. If the number's out in front, you can bring it up to the exponent to that number, okay? And the thing is that if the 6 is out front, that is technically not written correctly. All right, it needs to be just log with the base and then the expression afterwards, okay? All right, let's look at some more challenging ones over here. What do you think we should do first? Because there's like multiple things here.
Log x to the 4 minus
Plus log y to the second, very good. Do the power first and then bring them together.
so
Log,
x to the 4th y to the
very good. Log x to the 4th, y to the second. Okay? So do the power rule first before you do your product or your quotient. All right? Try number 5 and number 6.
Much simpler. This is from Article 5.
So you're doing 5 and 6. If you think you got it, try 7 and 8, all right? So make sure that you apply your power. I think folks have the power part down. Don't take the sign with it, okay? The sign tells you what you're going to be doing afterwards. If I'm going to be multiplying or dividing. What am I doing here? Dividing. So I'm going to divide x cubed by y to the 7th. Over here, I got a couple of powers. I'll have log x to the 5th minus log y to the 3rd plus log z squared. From here to condense it as 1, you read from left to right. Okay, kind of like order of operations. The only time you would change that is if there was a parentheses involved. So I'm going to first
Log
divide,
x 5th over y to
and then what am I going to do with this part?
the 3rd. Multiply z squared.
Okay, so you divide those two and then multiply it by z squared. If you wrote it as x to the 5th, z squared over y to the 3rd, that would still be correct. All right. Down here, what should I do first? You want to do your parentheses first, okay? Parentheses first. So I probably should do what here? This 4 and this 1/2. Don't let the ln throw you off. If there was a number out in front, what would you do?
ln y to the 4th
Bring it to the power. So ln y to the 4th plus the ln
z to the 1/2
z to the 1/2. What about out here?
ln x to the 8th.
You actually want to bring them together. Order of operations, deal with the parentheses first. Get that as one natural log.
So ln y 4th z half.
ln y 4th z to the 1/2. And now,
Which minus z divided.
and so now you divide. So, out of space, so you get
ln equals x over y to the 4th z to the 1/2.
okay? You guys try number 8. Try number 8. Try to condense it into one single logarithm. What should I do first? The parentheses. Okay, so with my first parenthesis here, what should I do first within that first parenthesis? deal with the power first, okay? So this is gonna become ln w to the fifth. And now what with the first parenthesis? Ln x w to the fifth. Very good, so that's my first parenthesis. That's what it simplifies down to be. Then I guess my second parenthesis, ln y squared ln z, ln y squared z. So I basically have ln x w to the fifth minus ln y squared z. So what should I do from here? And then you divide. Very good. Questions on condensing?
Does it matter if you put the x w or like switch them? Does it matter if we turn it on top?
Doesn't well it does matter which one's on top, but you could have put w to the fifth x instead and they'll still be the same thing. But you want to go from left to right, so that way you'll know that whatever's on the left will be on top of whatever's on the right. Let's go the other way. Let's expand it here, okay? So we're rewriting it so it's a sum or difference of all these logarithms. So basically we are making it longer. Here, log x to the third, y to the second. What operation do we see here? Multiplication, so that means we need to add them. So it's going to be log x to the third plus log y to the second. I'm still not done because I gotta what?
3 in front of the log. You gotta put it back to its original position.
3 log x plus
2 log
2 log y. That's right. I gotta bring down that power, and then it'll be fully expanded. It'll be the sum or difference of your logarithms, okay? So no powers, no multiplication, no division, okay? If I'm trying to expand it. If I'm trying to condense it, it should be multiplication, division with powers. Over here, I'm dividing, which means I need to do what?
ln x
Subtract ln of x minus ln of z squared.
2 ln
And yes, because the power's there, I need to bring it down to the front. Ln of x minus 2 ln of z. What about here for number 11? I got a whole bunch of things going on here.
parentheses 5. It shows 5 on
There's a 5 on y'all?
Yeah,
it's
it's
5.
5.
Is x 5?
That's the only difference?
Yeah,
Okay.
5 ln x
So you trying to go straight to it, huh?
plus 4 ln y. Parentheses around the subtract minus 9 ln z.
Wow, okay.
Can I have to test that?
Very nice. For those that might not have saw it right away, okay, split it up, and then there you go. All right, nice. What about 12?
I just stopped and waited.
Yeah.
Why'd you stop?
Because x and y is squared and I don't understand.
Is it?
Alright.
Is it?
Go ahead, Tyler.
Wouldn't it be parentheses log x plus log y? That's
Parentheses
two.
square.
Oh, sorry.
Big caps. Or wouldn't you
No,
just split? Wouldn't
not.
you just do
Not quite, Sam.
2 log x plus 2 log y? Yeah.
It'll be 2 log x plus 2 log y because that square is going to be distributed to.
It just pretty much condensed it to make it 2 on the ends of it.
And so then you would separate them,
2 log x.
and then
2 log.
2 log x plus 2 log y. Alright? Laundry. Hold on. Alright, so there you go. Those are your properties of logarithms, okay? Now, you'll do this more when we actually get to solving logarithms, okay? Knowing those properties will definitely help you out when it comes down to solving, okay? So, are there any questions?